Okay, let's look at quadrilaterals and their diagonals. Now, what is a diagonal? Here's a four-sided figure here, a quadrilateral, and we are talking about from one corner to the other corner. We break it up, we're putting an X in the center, right? Your diagonals from one corner to the other corner, other corner to the other corner, and we draw a line. All right. So let's look at the same things that we learned before, the same shapes, the parallelogram, rhombus, etc., etc. We're going to be looking at the diagonals, the properties of their diagonals. It's not telling me this is a kite, but anyways, okay. Right, here we go. The parallelogram. Let's look at the parallelogram. Now, when we draw some diagonals in this parallelogram, E is at the center here, right? So AE is equal to EC, right? Okay, so with regards to the angles and the sides, we sort of already know that the angles of the interior angles are 360. The sides, opposite sides, equal. We've shown that in the last video as well. We're going to be focusing on the diagonals. So we say that the diagonals of a parallelogram bisect each other. Remember, bisect, you break it up exactly into two parts, right? So from AE is equal to EC. So if this here is 5, this here is 5. Let's look at what happens in the diagonals of a rhombus, right? They bisect each other. Now, some noteworthy things about this rhombus. Let's see, right? Some noteworthy things about this rhombus. Yes, they bisect each other. Similarly to a parallelogram, they bisect. Can you see that this here is broken up in half, half. From here to here, half, half. Let's look at this now. From here to here, half, half, half here, half there. Okay. Now, something that's a bit different here, that's noteworthy in this rhombus, is that once these diagonals break up each other in half, we bisect what's happening here, man? Okay, like we were saying, that this is equal to this, that even the angles now bisect each other. So if this here was angle A was 60, here would be 30, 30. Same thing with this side, right? So I'm talking about here. See, they bisect each other, they bisect each other, bisect, bisect. Another very noteworthy thing about a rhombus, it's tested a lot in grade 10, 11, 12, is we can see that they intersect at 90 degrees. So what am I saying is that there is 90 degrees, making this 90 degrees, making all of this 90 degrees, right? Let's go on to the rectangle. Okay, rectangle. Now I want to do the rectangle and the square at the same time. I'm just showing you some highlighted things, how I remember it, right? You see, the square has all equal sides, right? The square has all equal sides. So does the rhombus, right? Do we remember that the rhombus bisected the angles? Yes. Rhombus and square. Actually, the rhombus is like a tilted square, or you can say they brothers, or however you want to remember it, whatever funny way you use to remember it. But can we see that here also in the square the angles are bisected? Can you also see that there's a 90 degrees, right? The difference here is that the diagonals are equal to each other. Yes, this line here is bisected, it's cut in half, right? But the length from A to the center and from C to the center is the same, we know that. Also from B to the center, sorry, it's labeled E, B, E and DE all are the same. So from here to here is 5, this is 5, this is 5, this here is 5 as well, right? So I hope you see some similar things here with the square. Now when it comes to the rectangle and the square, can you see, yes, same story, that it's bisected. AE bisect EC, yes, but BD is bisected at E. Also AE is equal to BE is equal to EC is equal to ED. Can you see that all of them are equal, right? So that's something that you're going to have to read up on this page. What page is 149. Also, let's go to the trap. We learned that the trap has one pair of parallel lines. Now see what happens here when we do this to a trap, to a trapezium. Now when we add in our diagonals, check this out. Can't you see the Z shape here? So this angle is equal to this angle, denoted by these dots that they have there, right? Also, can you see the Z shape here for your alternate angles? Here we go. There we go. This is equal to this, right? Very noteworthy, because when we go to advanced examples, we'll be able to see this and know that we've got alternate angles happening here, and our parallel lines would be AD and BC in this specific case, right? Now coming to this, now to the kite. We realize that angle A is equal to angle C in the previous videos, but we didn't say that angle D is equal to angle B, right? That's true. Now watch here. Angle D is bisected. Let me maybe zoom in to have a much clearer view. Yeah, there we go. Angle D, right, is bisected. Angle B is bisected. Can you see here now? A to C, the line 8, let me draw that. A to C is bisected. A to E is equal to E to C. And another thing we can notice is that they bisect at 90 degrees. Can we see that? So if that is 90, this is 90, this is 90, right? So please read up on that. Let's go to example 4 on page 150. Okay, so they've got your diagonals here, AC, BD. I'm not going to go to this too much in detail to try and save some time, right? So we've got all of this here. That, let's see, AC is equal to 50, AC is equal to 50, and AD is equal to 40. Okay, we got that there. Now calculate the following: all of these angles that are missing and all these angles that are missing, and they also ask us for the sides that are missing, the values of the sides that are missing, right? So let's do one thing at a time. Let's look at exactly how they tackled it. Now let's remember that they told us that this is a rectangle, so immediately this is 90 degrees, this is 90 degrees. You remember from our properties above? So let's look at it. We've got this now, we've got this, so this is 90. Let's zoom in. Okay, yes, there we are, there we go. So this is 90. So if they gave us a 65, we can say like 90 minus 65 will give us A2, which is 25. Let's look at the reasoning behind that. Interior angles of a triangle, and we know that that is going to be at 90 per corner there, right? So let's say like BE is equal to ED. BE is equal to ED. Why did it give me? Okay, they seem to have jumped the gun there. Okay, let's look at this here first, right? They told us that AC is equal to 50 centimeters, right? They told us AC is 50. So let's look at AC. AC is 50. Now we learned that AE is equal to EC. So if the whole thing is 50 and now it's bisected, from A to E is going to be 25, right? Because the whole thing is 50. We also learned that all of these diagonals are equal. So this is 25, 25, 25, 25. right? Also we can learn that this is 40, this here is 40. Remember, opposite sides are equal. Also another thing, now we realized that A2 was 25, right? Just to speed up, right? All the answers are written there, but let me just speed up, right? I'm speeding up to explain very quickly. Now we also realized that these lines here are parallel. Very important, because what can we learn from there? We can learn now. Let's just add in what we had here as well. This is also going to help us. Now, what can we learn here? Let's look at these parallel lines. Can you see the Z shape here? See that? So if this is 65, this here is 65, right? So, oh man, how do I cancel that? There we go. Okay. Alright, so we said that there is 65. I've shown you why. Now I'm not going to be writing the detail as to why, etc. to save time. Now we got that there was 65. There's our alternate angles. Our parallel lines we are talking about is AB and CD. I think I have to zoom this in and work completely with it. Yeah, okay, there we go. Now we've got that. Another thing I want to show you is, can you see in this triangle ABE? In triangle ABE, we have that these two sides are equal. So obviously, these two angles, are base angles, are going to be equal. Why? This is now an isosceles triangle. So this is also 65. Same story here. Can you see an isosceles? So this is also 65. Right? Now let's look at triangle AED. This triangle here. Can you see that that triangle now has equal sides? Hey, there's an isosceles. So these two base angles are going to be the same. Alright? So here we go. That is also 25. Now let us look at this Z shape here. Can you see that alternate angle there? So this is 25, this is also 25 here. Oh man, okay, let me get that. There we go. This is also 25. Here's an isosceles. So this is also 25. So obviously then, okay, then just one more missing piece of this puzzle is that this is a triangle ABE. Right? So obviously we can find internal angles of a triangle is 180. Sum of angles of a triangle is 180. 180 minus 65 minus 65, you'll get that. Same story. Vertical angles. You can even say vertically opposite angles. Right? Same story with this triangle here. AED. We're looking there and we're saying 180 minus 25 minus 25, you will get that. And that will equal there. You sort out all the angles in this rectangle. Right? Obviously all of the explanation is on the right hand side there. There's a long explanation. To save time, I didn't want to write out and refer to each thing, right? So exercise 2, that you have to sort out. Look at your schedule. There's it there, and sort that there out, right? If that was exercise 2, then let's go. Okay, congruent shapes. Now we've learned about similar triangles and congruent triangles. I always tell my learners, and I teach both sections actually together to get a proper understanding. Similar triangles are similar, but they're not the same. Congruent triangles are exactly the same, right? So we're going to be starting off with congruent shapes now, right? We're not really triangles. We're going to be going to triangles, but we're doing congruent shapes. Congruent means exactly the same. They are the exact same shape, right? So let's look at this this polygon here, right? So we can see that this is the exact same shape. I'm not going to call out the figures, but we can see that the angles are all the same. The interior angles, the sizes of the sides are all the same as well, right? So identicals in size and shape. Size, we're talking about the size of it, the measurement 70 mm, 70 millimeters. The shape of the polygon, we're talking about the internal angles are the same, etc. Right? Let's move on. So then here they tell you a whole lot of stories about how. Okay, let's look into, just to refresh our memory from grade 8. Right, now we're saying angle A is equal to angle F, angle A is equal to angle F, right? Angle B is equal to angle G, etc. We're making these comparisons. How is this shape equal to the shape? How is the shape exactly as that shape? Now we look at which are the corresponding angles. We've done our angles first. Here we've done our angles first, then we are doing our sides, right? Let's look at our conclusion, right? Corresponding angles and sides of two congruent polygons are equal, right? So what I'm saying, if it's the same angle, same side, these two shapes are congruent. All right, then let's look at this next one. Okay, in this next one, the corresponding angles and sides are congruent, then the triangles are equal. They're exactly the same, right? So it's similar to what we just learned just now. Just to show you, let's just do a quick. Angle A is equal to angle D, 45 is equal to angle I. Let's find out I. Okay, there's a tiny I there. Don't think so you can really see that, right? So we're saying that those angles, they are equal. Let's put a yellow dot. And the next one, B, E, and H. Angle B, angle E, and angle H. Can you see that? So what we did was we proved that all three of these triangles, 1, 2, 3, all of them are the same, exactly the same. Their sizes are the same. See, 66, 97, and 130. 66, 97, 130. 66, 97, 130. All of them are exactly the same. Why? They've got the sides and the angles are the same. Okay, now we're going to learn the symbol for congruency. The symbol looks like that. Now how I remember this is, remember I said that similar is similar but not the same, and congruent is exactly the same. Now we learned that the equal to sign is for something that is exactly the same. So in this case, we just add another line there and say that this is congruent, is exactly the same. Similar will go the opposite way. This is similar, this is congruent. That's how I remember it. You can make whatever way you find easiest to remember it, right? Then we're gonna say something like this. Triangle ABC, this is how you read it out in words. Triangle ABC is congruent to triangle DEF. This triangle's name, let me just get this, is ABC. That's how it's named, right? This is DEF. Now, there's two ways of naming this. Let's say if we didn't have these measurements, right? Let's only look at these angles. Now, naming a triangle is very important. Okay, let me be more specific. Getting this part here is extremely important. You get 1 mark for that. Naming these triangles, right? So now, why can't I just say triangle ABC is congruent to DFE, right? Why I can't say that? See, when I go to ABC, I went to 45, 105, 35. So here, see, I went to A, B, C. Let me write that down. I went to A, then B, then C. Alright? That's how I went there. So you say in your mind, I went to 45, then I went to 105, then I went to 35. 45, 105, 35. D, So that is why you've got to now name this DEF. So that is the reason why we say that triangle ABC is congruent to DEF. Can you see how we name that? Right? Now let's see using our sides. Let's see using our sides. Let me just go out a bit. Okay, now if we have sides, we imagining that we don't have these angles. The question does not give us these angles. Now we're looking here now. We got a 66. Let's see if we want to move something called ABC, right? If we want to move ABC, right? So if you're moving ABC, right? If you're moving ABC, we went from 66, 97, 130. So let's see, 66, 97, 130, DEF, right? So that's why we're going to say that triangle ABC is congruent to DEF, right? That's what all these explanations here say to you. Now let us focus on this here. This is a good one now. Okay, where's my, just one second. Alright, I got the shape neatly. Now we should be focusing on this shape, right? Yes, everything is explained there, but let's look at this here, right? Now let's look at just our angles. Let's start with angles. Now if we name this triangle ABC, right? We went from a closed dot to an X to an arc. Let's say closed dot X arc, right? So we need to find that combination on this triangle here on the top. So we're gonna say that triangle ABC, we can say that this triangle ABC is congruent to what, right? ABC is congruent to what? Let's check it out. We had the dot X and then the arc, dot X arc, DEC, right? There, okay, there's the actual answer here, right? They've done that for you. Can you see that? Dot X arc, dot X arc. All right. So let's say if we're looking at the sides, we've done the angles now. So if I've got A, B, C, I went to 2 slash 1 slash 3 slash. Can you see that? Let me draw this. 2 slash 1 slash 3 slash. Let's see where we find something corresponding with that. I can't start here. I got a 1 slash. I'm teaching how to think, right? So we said 2, 1, and then 3. There's 2 there. So if I do this here, I'm showing you, right? 2 slash 3 slash. No, I can't go like that. Let's go this way. 2 slash 1 slash 3 slash. Yes, I went like this. Sorry, I went like this. So I went D, E, C. Are we together on that? How you name this, right? Okay, so if you look at example 6 now, long story short, they try and find out R. Obviously we can do that with internal angles of a triangle and find out U. They found out that R is equal to U is equal to 130, right? Equal to 130. Then what I'm interested in is naming this triangle. You're telling me that let's go to PQR, right? PQR, just using our angles. PQR, we went to 20, 30, then this we said was 130. Let's just put this yellow dot. What's happening? Okay, this yellow dot, right? So we went to 20, 30, yellow dot, 20, 30, yellow dot. So I'm saying PQR, is going to be congruent to 20, 30, yellow dot, STU. Can you see that? If we went 6.8, 3.7, and 4.8, 6.8, 3.7, 4.8, we're going like this. I hope can you see this flow like this, right? That's what we're looking at. Okay, we're now looking at the 4 cases of congruency, right? So 4 cases: side, side, side. Let's see what page we want us to show you. We're looking at page 154. This would be, right? We got side, 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 angle, angle, side, angle, side. Yes, you can highlight the stuff there. And okay, there's a 4th one: right angle, hypotenuse, and a side. Now, okay, we'll be doing examples like that soon. Okay, actually, there's it right here. Right there. Okay, yes, there's it here. Now, let's look at this. We've got a 52, 53, and a 39. 52, 33, 39. Hey, I've got a side, side, and a side. Now let's check. Let's figure this out. We've got AC is equal to DF. Can you see that? 52. That's a 52 pair of the sides there. Then we've got, okay, let's just read how they did it. AB is equal to DE. AB, DE. Can you see the 53, 53? Yes. So here's our one side. BC and EF. BC, EF. Right? So we got a side. I say we got a side. We got a side. And you got another side. That is how we got a side, side, side. Let's look at the next one. Now, here I've got, let's look at this now. When I say look at this, we are looking at this part here, not that C there. Right? We're looking at this part here. Now we're looking at it and we're saying, yeah, I got a 34, 34. So I know, there we go. There's that angle happening there. I got an 85 and 85. Wow. There's my 85 and 85. I got a 52, 52. Okay, let me put this all on paper now. See, I'm teaching you how to think first, and then you think before you ink. Now, we got AC is equal to DF. Yes, that's a side. Can you see how you write a side? AC is equal to DF. That's a line, right? AC is a line, DF is a line. Then we're writing our angles. Please, when you're writing angles, don't forget this symbol on the top, right? So we're saying angle A is equal to angle D, right? Angle B is equal to angle E. Side, angle, angle. We got one side. There's our side. Wait, let me use a highlighter. We got one side, and we got a. Can you see that one side? Wow. Can you see that one side there? And we got angle and an angle, right? Okay. Here, side, angle, side, side 52. We got an angle here 34 and 53. I think you can see that, right? That's quite basic. That's grade stuff. Okay, how would you know whether we're using the RHS or not? This right angle, as soon as you see this right angle, we are talking about RHS. You've got your right angle, we check our hypotenuse. Hypotenuse is opposite your right angle. So we are talking about this line here. We are talking about this line here. Can you see the hypotenuse here is 50? Hypotenuse here is 50. Yes, so that's how we got our hypotenuse. And we need at least one other side, right? So we're looking at this here is 40. This is 40. We got a right angle, we got hypotenuse, and we have our side, right? Then you're going to be doing exercise 3 according to the sheet that I showed you.